You know what they say, another day, another dollar. Let's do Advent of Code Day 3. And I'm probably going to try and use an actual editor this time. Let's see. Rucksack, I don't like the sound of that. Reminds me of dynamic programming. Maybe there's some simple approach. One elf has an important job of loading all the rucksacks with supplies for the jungle journey. Unfortunately, that elf didn't quite follow through the packing instructions, and so a few items need to be rearranged. Each rucksack has 2 large compartments. All items of a given type are meant to go into exactly one of 2 compartments. The elf that did the packing failed to follow this rule for exactly 1 item type per rucksack. The elves have made a list of all the items currently in each rucksack, but they need your help finding the errors. Every item type is identified by a single lowercase or uppercase letter. That is, A and capital A refer to different types of items. The list of items for each rucksack is given as characters, all on a single line. A given rucksack always has the same number of items in each of its 2 compartments. So the first half of the characters represent items in the first compartment, while the second half of the characters represent items in the second compartment. For example, suppose you have the following list of contents from 6 rucksacks. First rucksack contains all of these items, which means that its first compartment contains the item of the first half, while the second compartment contains the items of the second half. Okay, the only item type that appears in both compartments is lowercase p. Okay. Got it. To help prioritize item rearrangements, every item type can be converted to a priority. Lowercase items type A through Z have priorities 1 through 26. Uppercase items A through Z have priorities 27 through 52. I don't know why I'm saying Z. I'm American, okay? This is Z. In the above example, the priorities of the item type that appears in both compartments of each rucksack is 16, 38, 42, 22, 20, 19. The sum of these is 157. Find the item type that appears in both compartments of each rucksack. What is the sum of the priorities of those item types? Wow. Okay, I don't think this is rucksack problem type. What am I thinking about here? Programming sack dynamic. What is that called? Knapsack. Okay, it's rucksack, not related to knapsack, so that's a relief. Let's see if we can get it. Okay, let's first make sure console that we can run TypeScript project. So we need Node.ts, something like that. TS on day 3. Right. TS node. Okay, cool. Alright, to the problem. We're gonna need our example input. We're gonna need our example input. And then the first step, function convert to halves. So this function is going to take all of these inputs. In this case, it'll create 6 different inventories, each with 2 compartments. The compartments will be composed of the first and second halves of each string. So that inventories in strings equal input dot split on new line, and then let inventories equal an empty array inventory strings dot map will be each string. We want to slice the string on stir.slice 0 to stir.length divide by 2, making some assumptions about the lengths that they're all perfectly divisible, or that there's an equal amount of items in each compartment. We'll see how that works out. And then this one will be stir.slice stir.length divide by 2 to stir.length. And this one will be let's see if this is working. Convert input console.log. Yep, getting type errors. Okay. The joy of using a typed language. Input, this is a string. And this is also a string. What is the problem? Do I have to initialize a variable here? Okay, nice. Let's make sure this matches. Yep, so far so good. Okay. Okay. I watched a short today of Pop Smoke buying sneakers using only ad libs. Pop Smoke ad-lib sneakers. Probably won't be able to hear it, but funny guy. R.I.P. Okay, so we have our halves. Now it would be nice to find the overlapping character. And I think optimal way to do this would be convert one compartment to a hash map, and then iterate over every character in the other compartment, see if it exists in the hash map. But we'll just go with an n-squared approach for simplicity. Function find overlap, find shared, and this will take in a compartments, which is type array of 2 strings. Maybe I can specify that. Cool. Let first compartment equal compartments 0. Delete second compartment. Could have also destructure assignmented that. But anyway, first comp dot for each item. Oh, I can't do for each on a string. So we'll go back to the trusty for loop. And we ++I for performance reasons. If you know, you know. If first, maybe second comp dot find, first component I doesn't equal 0. Okay, JS find. JS string find. Search. Okay. Doesn't equal -1. Then we're going to return first component I. So now if we find an item in both compartments, we return that from this function, find shared. Let's make sure that works. Inventories.map for each inventory. We are going to console.log find shared of inventory. How are we doing on time here? 15 minutes. I haven't submitted anything. It's time to hurry up. Time to go Velma mode, hacker mode, according to Finley King. Stream. Oh. Let's just set up a compile command. For some reason, TypeScript isn't detecting inventories as being an array of arrays of 2 strings. So maybe this type is too... oh! The power of Emacs. Might as well just shut down while you're using it. Bear with me, everybody. This one's getting me. Yeah, I know that compartments needs a type in order to compile, so I'm giving it. Let's just try. TS. Array type. There we go. G. It says that G is the common element. Let's see. Second rucksack's compartment contains these things. Oh. We're not getting a matching split on inventory 2. For some reason there's this tab here. Maybe that's messing things up. No, actually that is the same. Oops. Except for this. So we have duplicate something's going on with our convert to halves. Or my convert to halves. It's my problem, okay? I'm sure that you're looking at this and seeing what I've done wrong, but I don't. Oh, I don't. Yeah, so something troubling me here is what appears to be 4 empty characters at the start of the inventories. So where could that be coming from? Probably here, where I put them in. Is there a better way to do a multi-line? I'm not sure. P-L P capital P VTS. Okay, great. Now we just need to convert our overlapping items here into a priority value and sum them all up. First I was thinking this is map and reduce, but as my reduce knowledge grows, I'm thinking I can do this all in one step if I just convert item, which will be a character. If I get the ASCII representation of that, character code 0 to 128 ASCII chart. We want to map 65 to 26 and 97 to 1. So if the item is greater than ASCII representation of Z, which is 90, then that means that it's a lowercase character, and we will return just item.carcode at 0 minus 97 plus, oh no, minus 96, I believe. Because lowercase a is 97, we want it to be 1. Okay, this makes sense in my head, but that doesn't always mean that it will work, of course. Thank you, ASCII Dictionary. Thank you, Emoji Dictionary. And then we want A to be minus 64. Oh no, that's not what we want. We want 65 minus 65 plus 27. Yeah. Yep. That's a new format of reduce for me. Don't know if it'll work, but it's worth trying. Let overlaps equal shared items is an array of all the shared items, and then we pass in this list of shared items to some priorities, and we want to log that. Now how am I doing on time? 27 minutes and still no answer. Maybe we'll have it now. Nope. So we need to type for item. This is going to be a string. Cur is a number. Overlap says any type. It's a string array. Technically, it'd be a car array. Wow, we're really doing things here. I'm gonna have to readjust the seat to overcome this one. Yeah, this reduce is too complicated. I think cur is supposed to be a string. So let's just first get the priorities, and then we'll sum them up separately. So problem on line 38. String or undefined. It's not assignable to string. Undefined array. Find shared was assign types, return type string or undefined, because technically we could not be finding an overlapped item, but I think the raw input will always contain an overlap item, so let's just return some bogus thing here in case we fall through, and that's just to appease the compiler. Alright, 157, cool, that works. Now let's do it with the big boy input. Let's test input equal this, and then can we fold? Space Z fold. Oh, whoop. Z close. Fold. Oh. Tried to get too fancy there. It'd be nice to fold this down so that it's not 300 lines of garbage in my file, but that would involve reading another file, yada yada yada. So we will do this and replace raw input with test input, and then recompile. 7,797. Not the right answer. 7797. Well, you can't win them all. 36 minutes. Wrong answer. And maybe I didn't paste this in properly. Okay, now the last line matches. 7821. That's good. Oh, gotta wait 5 seconds before trying. 7821. There's the right answer. Great. Part 2. As you finish identifying the misplaced items, the elves come to you with another issue. For safety, the elves are divided into groups of 3. Every elf carries a badge that identifies their group. For efficiency, within each group of 3 elves, the badge is the only item type carried by all 3 elves. Okay. That is, if a group's badge is of item type B, then all 3 elves will have the item type B somewhere in the rucksack. And at most 2 of the elves will be carrying any other item type. 2 of the elves. Okay. The problem is that someone forgot to put this year's updated authenticity sticker on the badge. All these badges need to be pulled out of the rucksack so the new authenticity stickers can be attached. Additionally, nobody wrote down which item corresponds to each group's badge. The only way to tell which item is the right one between finding the item type that is common between all 3 elves in each group. Every set of 3 lines in your list corresponds to a single group, but each group can have a different badge item type. So in the above example, the first group's rucksack are the first 3 lines, right? The second group's rucksack items are the next 3 lines. Okay, in the first group, the only item that appears in all 3 rucksacks is lowercase r. This must be their badges. In the second group, their badge item type must be Z. There's a Z in each of the rucksacks. Priorities for these items must still be found to organize the sticker before the sticker attachment efforts. Here they are: 18R for the first group, 52Z for the second group. Some of these is 70. Find the item type that corresponds to the badges of each 3 elf groups. Some of the priorities. Okay, so I think this is similar, of course, but instead of treating each rucksack separately, we are just finding the overlapping item in sets of 3 rucksacks. So our fancy little n squared algorithm here will then become n cubed, and R. Yeah, I don't think the halves are still playing a part in this. No. Yeah, so we don't have to split the inventories in half anymore. Now if we find an item in in two rucksacks, we'll search the third rucksack for the same item. Yeah. Group inventories. Sorry to go silent mode. Just have to focus. 2,634. Again with the wrong answer. Oh, day 3. What are you doing to me, day 3? A, B, C, D, E, F, G. That is 7. I think I know what's going on. There's a little boneheaded with this find shared function. So if we instead just take the logical AND of both searches, I think this might produce a different output. But it didn't. 2,634. Uh-huh. That's why you don't copy and paste. I was assigning third inventory value as the second inventory. Let's see if this changes things. 2,752. I'm feeling good about that. 2,752. Nice. Okay, that's day 3, everybody. Took me just under an hour. So at this pace, if I want to catch up, I have 4 more hours of work. And then I'd have 9 hours left until day 8. That's kind of daunting. I think I'm going to take a half-hour break or so, and then try and tackle number 4. Catch you next time.